My name is Bains, and today I'll be discussing prenatal bisphenol A exposure and childhood neurodevelopment. This presentation examines how exposure to BPA during pregnancy can affect brain development and behavior in children, using both human epidemiological studies and experimental evidence. Brain development during pregnancy relies on tightly regulated hormonal signals that guide neuron growth, differentiation, and circuit formation. Endocrine disrupting chemicals can interfere with these signals. Bisphenol A, or BPA, has received significant attention because it mimics hormones involved in neurodevelopment and is widely present in the environment. I put a picture of some sources of endocrine disruptors, and as you can tell, bisphenol A is at the top. So this comes to the question of what is BPA? BPA is an industrial chemical used in polycarbonate plastics and epoxy resins, such as food containers and can linings. Most people are exposed through diet, but exposure is continuous. And importantly, BPA can cross the placenta, meaning that fetuses are exposed during critical stages of brain development. So, why does prenatal exposure matter? Prenatal life includes critical windows where the brain is especially sensitive to disruption. Hormonal interference during these periods can permanently alter neural development. Unlike acute neurotoxins, BPA causes subtle changes that may not appear until childhood, affecting behavior and cognition. Prospective birth cohort studies show consistent links between prenatal BPA exposure and neurodevelopmental outcomes. Children exposed prenatally show increased behavioral problems, reduced attention, and lower executive function. Many studies also report sex-specific effects, suggesting hormone-mediated mechanisms. One major example is a Chinese birth cohort study by Huang and colleagues in 2022. They found that higher maternal BPA levels during pregnancy were associated with poorer cognitive performance and increased behavioral problems in early childhood. These findings remain significant even after adjusting for socioeconomic and environmental factors. Experimental studies help explain how BPA causes these effects. Human-induced pluripotent stem cell models show that BPA disrupts neuronal differentiation and neurite growth. Zebrafish embryos exposed to BPA show altered brain development and abnormal behavior, even at an environmentally relevant doses. This is what a zebrafish looks like. BPA acts primarily as an endocrine disruptor. It interferes with estrogen and thyroid hormone signaling, both of which are essential for brain development. These disruptions affect gene expression, synaptic formation, and sexually dimorphic brain development, explaining why males and females can be affected differently. Because BPA exposure is so widespread, even small effects can have major population-level impacts. Prenatal exposure represents a preventable risk factor for neurodevelopmental disorders. Reducing BPA exposure during pregnancy could significantly improve childhood behavioral and cognitive outcomes. In conclusion, evidence from human studies, systemic reviews, and experimental models consistently show that prenatal BPA exposure negatively affects neurodevelopment. These effects are biologically plausible, persistent, and occur at real-world exposure levels. Reducing BPA exposure during pregnancy is an important step in protecting child brain development. Thank you so much for watching my presentation. I hope you enjoy. Additionally, these are my sources. Thank you.